So if you take a look here, what we have is 1.7 functions. And in functions, and we're going to have a goal, we're going to determine whether a relation is a function, and then we're also going to find linear equations. So again, this is 1.7 function. You should be writing date in the upper right hand corner and writing 1.7 function. So let's first talk about what is function notation. Function notation are equations that are functions that can be written in this form. So if you look right here, we do have an equation. We have the equation y equals 3x minus 8. Okay, this is an equation. We know it's an equation because it's an equal sign. Some of you may already notice, hey, that equation is in slope-intercept form. Well, to write it as function notation, you write it with the f, the parentheses, the x in place of the y. So how you would read this is you would read this as f of x. So that's what that means. F of x equals 3x minus 8. F of x is the same thing as a y. Function notation, okay? All it's saying is if you input a value in, what's the output? What's the function of it? Now you can see f of x like that. You may also see something like this, g of x. You may see something h of x. And another one you might see is h of t. And h of t is a lot of times when we were dealing with time for here. But again, how you read these, so this is f of x for here. And all function notation, again, is just basically a different way to write an equation. Y and f of x are interchangeable. They mean the same thing. Let's just do another example. So if I have y equals 1/2 x plus 4, the equivalent to it, or the function notation, is f of x equals 1/2 x plus 4. They are the exact same thing, okay? Function notation is the same thing as an equation. What we deal with function notation is we deal with when we have an input, what's the output? And I'm going to go over that here. So we're going to look at these function values. I'm going to give you a chance to write this down. So for f of x equals 3x minus 4, we want to find each value. So f of x, we are going to use the f function. How I know I'm using my f function is there's an f in front. So this is read f of 4. As you can see here with this, the 4 is taking place of the x, because normally this would be written as f of x. Well, in place of the x, we're putting a 4. So in this equation, okay, we have f of x equals 3x minus 4. Well, on f of 4, because 4 is taking place of the x, 4 will take place of the x here. So we have 3 times 4 minus 4. Now, we just do math. 3 times 4 is 12. 12 minus 4 is 8. So f of 4 equals 8. Meaning, when I put 4 in place of x in this value, the output is going to be 8. So this 4 takes place of the x in the function. 4 is going to take place of the x in the equation or the expression. That's what this says. So let's look at f of -5. F of -5, well, we're going to use the f function. So we're going to have 3. Well, -5 is taking place of the x. So we're going to have -5 take place of this x. And now we just do the math. We have 3 times -5, which is -15. -15 minus 4 is going to give us -19. So we have f of -5 equals -19. So this is the function notation. Function notation, you find the function given. So here f of x equals 3x minus 4. We want to find f of 4, so we put 4 in place of the x, and then we solve to get a value. Here we want f of -5. We put -5 in place of the x, and then we solve for our value. Again, function notation, it's just basically another way of doing substitution. So I want you to try these ones on your own. And yes, we do have a fraction. You're going to substitute it in. You can do this calculations. So to do on your own, I want you to pause the recording. Or not pause the recording, pause the video. And I want you to try these on your own. And then when you try them, you're going to then hit play and you're going to see if you got them correct. All right, so if we take a look here, f of 1/2, you should have gotten 0. And f of -3, you should have gotten -42. Next one. We have still f of x equals 3x minus 4. So here we have f of 2y. Same concept. Even though I have a variable here, I'm still doing the same thing. What is placed in place of the x on this function? Well, it's 2y. So I'm going to replace the x in here with 2y. Again, it's just another way of doing substitution. Well, what's 3 times 2y? That's going to give me 6y minus 4. These are not like terms, so I'm done. So then I have f of 2y equals 6y minus 4. Let's take a look at f of x plus 2. Well, in place of x is x plus 2. So I'm going to put in place of x, x plus 2. Minus 4. Now we have distribution. So we have 3x plus 6 minus 4. We do have a set of like terms. Our like terms are 6 and -4. So we end up with 3x plus 2 equals . So f of x plus 2 is 3x plus 2. So these are this. Again, we didn't add just numbers in place. We had actual variables as well. So whatever is in place of the x is what you substitute in. All right, so I want you to try this on your own. So I want you to pause your video, substitute these in, and then play the video to see if you got it correctly. So as you can see here, for this one, f of -7x, so you got -84x minus 6. And f of -3m plus 2, you should have gotten -36m plus 18. One thing I forgot to note to you guys on the other on your own is remember I changed up your function here. So your function can represent various types here. So far, every time I've used f of x. And on the next slide, I'm going to change something up for you a little bit. Now we have two different types of functions. We have an f function and we have a g function. And on here, for a, we want f of 3 plus g of -2. So what it's doing, what it's telling you is it wants to find f of 3, so you need to plug 3 into the f function. You want to find g of -2, you're going to plug -2 into the g function. And then you're going to take those answers and add them together. And I'm going to show you what I mean. So let's do f of 3 first. So f of 3 equals, oh, this is the f function. So it's going to be 3 times 3 minus 4. 3 times 3 is 12. 12 minus 4 is 8. Then I'm going to do my g of -2. So I'm going to choose a different color. Let's go with blue. Then I'm going to do my g of -2. So this is going to be -2 squared plus 4 times -2. -2 squared is 4. 4 times -2 is -8. So we have 4 minus 8, which is -4. And now what's it tell me to do? Here's my f function. Here's my g of -2. It tells me to add the two. So I'm going to add them. 8 plus -4 is 4. So f of 3 plus g of -2 is just 4. Let's look at this next one here. F of 2 minus g of -3. F of 2, we're going to go f of 2 equals 3 times 2 minus 4. So this is 6 minus 4, which is 2. G of -3 equals -3 squared plus 4 times -3. -3 squared is 9. 4 times -3 is -12. 9 minus 12 is -3. So we have f of 2, which is 2, minus g of -3, which is -3. 2 minuses turn into a plus. So our answer is 5. So when you have two different functions being added or subtracted together, solve one function, solve the other function, then perform the operation that's between them. I want to add a blank screen, so I want to show you guys something. Let's go with insert blank screen. All right, let's say I give you guys, let's say f of x equals 3x minus 7. And let's say I want to find f of 2 plus 4. This is just like the last one. Where I want to find f of 2, we're going to get an answer, and then we're going to add 4 to the end. So f of 2 plus 4. So I'm going to take f of 2, which is going to be 3 times 2 minus 7. So 3 times 2 is 6. 6 minus 7, we get -1. Here's f of 2. Now, what does it tell me to do to f of 2? It tells me to add 4. So now I'm going to write plus 4. So my answer is 3. So I took the function that I found f of 2, I got an answer, and then I added 4 and gave me a 3. So this is function notation. All function notation is just like substitution on steroids. Okay. Hopefully you guys got it. If you have any questions, make sure you ask after watching the video as you're working on the practices.